you need to go over it again. All right, so 2x cubed, right? Let's see what happens. If I pull out 2x cubed for the GCF. Then I get x cubed minus 11x squared plus 24x plus 36. Is that right? Did I divide correctly? Okay. But when I group that, it won't help me out, will it? Because yeah. Let's see, let me think about this. Well, let's not waste time trying to do it vacuum-wise. But this tells me what, right here? What's that tell me one of the zeros is? 0, right? And how many times does it work? 3. You see that? Because I can write, 2x cubed equals 0, divide by 2, which is still 0, and then take the cube root, which is still 0, right? So this has a multiplicity of 3. Now I can just put that part in my calculator and look at it, okay? So I'm going to do just that part, x cubed, since I already took out the 2x cubed, minus 11 x squared plus 24x plus 36. Ooh, it bounced and it went straight through, right? That looks like -1. Well, let's do this. Okay, make it go bigger. You guys can see. That looks like -1, and then 1, 2, 3, 4, 5. That looks like a 6. It's bouncing, so what am I thinking happened at 6? Multiplicity of 2, even, right? When it bounces, it's even, so it works at least twice, right? All right, let me look at my table to make sure that's a -1 and that's a 6. How do I get the table? Second graph. All right, there's the -1, so that was right. And then, yeah, 6. Okay. You following along there, Coli? Or are you playing some kind of game? Okay. So if this works 3 times, this works once, and this works twice, did I get all of them? Yeah. How do I check to make sure the 6 worked twice? You can do synthetic division, right? But it's going to work twice. Okay? So what we would have to do if we did synthetic division is put a 0 in for x squared, a 0 in for x, and a 0 in for the constant when I do that synthetic division stuff. Okay? Or if you want to go by this one, we could go 1, we could put the 6 in, and then 1 for the x cubed, -11, 24, and 36. Okay, what's 6 times 1? When you add those, 6 times -5. When I add these, 6 times -6. And then it should work again. 1 times 6 is 6. 1 times 6 is 6. Okay. Now, just going a little further here, because we're going to end up doing this anyway. Pay attention to this. when I wrote these, what was this exponent? What was this exponent? X to what power? Third. So what's this one? Second. So what's this? First. So this right here, this little binomial is 1x plus 1 equals 0. What do you get when you solve that? Not 1. What are you going to do with that 1? You're going to get negative 1, which is what? That one. Okay? We're going to get to the point where we can't see all of them. All right? So what we're going to have to do, the ones we can see and figure out with our calculator, we're going to have to use synthetic division and reduce this big old polynomial down to a polynomial that we can solve by hand. Either a linear one, or a lot of times it'll be a quadratic one, where we can use the quadratic formula if we have to. Okay? Nothing that we haven't done already, but we're going to get to that point. Okay, so synthetic division is going to help us reduce our polynomial down to something we can handle and do by hand. Because some of them are going to be imaginary in the future here, the near future. Okay? You know, how did we get imaginary numbers? Anybody, how do we get them?
No, dividing
Square root of a negative, right? We're going to get to that point where we'll have some square root of negatives. We'll have some non-real zeros or imaginary zeros, okay? So we're going to have to do some synthetic division, some simplification of our polynomial so that we can use, you know, our ways of solving quadratics. Okay? So just something that will be added to this here. Okay? So, there were lots of question marks on your homework. And the first time we go over this, that's usually how it is. So it's okay. All right? But let's make sure we understand after we go through them. All right, so we did 15 to 22, right? All right, number 15 comes out to be -3 and +3. It doesn't say, but one of them has a multiplicity, I think, right? But you didn't have to tell us that for number 15. 16, -1, 0, and 1 were the answers. For 17, it was -8, 0, and 8. For 18, it was positive and negative square root of 6. 19 was 5 halves, or 2.5, and plus or minus the square root of 2, which is 1.414 if you did the decimal. And 20 was -2, -3/4, and +1. Okay? So those you didn't have to state multiplicity, but there could have been multiplicity with those. Any of those before we do the last two? You want to go over?
Can you do number 15, please?
Sure. So we got x cubed plus 3x squared minus 9x. 3x squared minus 9 equals 27, right? So the first thing we got to do is move the 27 over. So it's equal to 0. And we're going to group it. All right, so I'm going to put these three, or these two together. Oops, I want like that. Plus sign in between. -9x minus 27 equals 0. Okay? So, we okay with that part? All right, now what's the GCF of the first group? X squared. What's the GCF for the second group? -9. Good. All right. This x cubed divided by x squared is x, and 3x squared divided by x squared is 3. -9x divided by -9 is x, and -27 divided by -9 is +3. So the red one's x plus 3, and then the black factor is x squared minus 9. But what do we call that x squared minus 9? Difference of squares. So I have to finish it. This x plus 3 doesn't change, but this turns into square root of x squared, square root of 9, one's plus, one's minus. So that's it in factored form. And then, when I set them equal to 0, this is the step we're supposed to do here, but we all know by looking at it that the answer was -3, right? And this one is also -3. And then this one's what? +3. So there is actually multiplicity in this one, but they didn't ask you to state that. But, -3 has a multiplicity of 2, and +3 has 1. And there's our 3, because it started out as an x cubed one, right? Our 3 zeros. And that was by factoring. Back.
Wait, so basically what we're doing is just factoring and then finding the opposite of whatever it was?
Right, what makes it 0, right?
Oh.
If I put -3 or +3 into this original problem, this side would be 27.
Okay.
All right. All right. Any others up to 20 there? You guys want to look at 18? Okay. We've got x to the 4th minus 12x squared. I think it's -36, right? Yeah. All right, so bring this 36 over. So I have this trinomial then, and I add the 36 when I bring it over. And actually, there's no GCF, but the first and the third one are positive perfect squares, right? So we did that 1, 2, 3 test thing, John, and 1 was the square root of that, which was x squared, and 2 was the square root of that, which was 6, and then what did I do to get number 3? I multiplied these, and what was I looking at, the relationship between this and that? What did the relationship have to be for it to be one of these special trinomials? Had to be half, right? Is that half of the middle? Half of 12? Right. So I could factor this like this if I wanted to then. And then number 1 goes in the front. Whoever's in front of the B goes between them, and number 2 is in the back. Okay. So then we solve that equation. So what do I do first to solve that? Plus the 6, right? And then what do I do to get rid of the squared part? We go square root, right? And that's x equals the square root of 6. But what are we supposed to remember? Plus or minus. And each one of those works how many times? Twice. So positive square root of 6 and negative square root of 6 has a multiplicity of 2. So if I graph it, I'll go ahead and graph it just to show you what's going to happen at positive square root of 6 and negative square root of 6 when you look at that graph. It's going to bounce. Okay. We go here, y equals, clear it out, x to the fourth minus 12x squared plus 36. See? Okay. And if you wanted to, it's okay with me if you found that there. Now, will that show up? Will those show up in my table? No, why? Why won't it show up? Is that a whole number? No, it won't show up. Your table's set up to show whole numbers, right? Okay, so let me show you how to find them. Now, they'll get the decimal answer, but I'll be okay with that, even though I like that answer better. All right, so you can hit second trace. The button's right next to graph. Okay, and we're looking for what? What are these answers called? No. They're called zeros, right? Or roots. So number 2 says 0, right? So that's what I'm going to hit now. 2. Now it says left bound. Okay. Right now, whenever you do this the first time, it always starts at the y-intercept. My y-intercept is 0, 36. So it goes way up to 36 before it starts coming back down. Okay? Now, left bound. The calculator knows there could be more than one 0. So it wants you to give it boundaries of where to look for this 0. So that's what left bound means. Get to the left of the point you're looking for. All right? So I'm going to get my cursor over here to the left of it. Now, this is what it looks like, a quick sketch of it. Okay? I'm looking for this point and this point, which we know is negative square root of 6, and we already know the answers, right? But when it asks for left bound, okay, you got to get your cursor there. That makes sense? Left of the point you're looking for. If you're looking for this one, you want it over here. You're still left of it. Then it's going to ask for right bound. So then you're going to make sure your cursor's over to the right of it. Okay? So this is something you want to pay attention to so that you can use your calculator to help you find these ones that don't show up in your table. Okay? So this is why we got these. This kind of stuff. Why I told you need this type of calculator at the beginning of the year, because this helps us. We use it as a tool to help us find some answers to stuff. Instead of doing it the way I had to learn, which took forever, but we could find it. All right, so back to the calculator. Left bound. These two numbers tell me where the cursor is. So when I hit left arrow, now the cursor's there. All right, you guys can hold it down. If I hold it down, it'll go crazy. But pretty soon, it's at 19. Once we get it less than 10, we'll start to be able to see it blinking over here. Right there, you can barely see it, but that's 9.6 for the Y. There it is, that's 5.5. All right, so I'm moving along here till I get left of that point that I'm looking for, that 0. Okay, so once I get left of it, like I am now, I hit enter. Then it asks for the right bound. So I got to go right and go around it and get right of it. And then I hit enter. So now the calculator knows what 0 you're looking for. You gave it some boundaries. it says guess up there now, right? So you have to hit enter one more time, and then it'll give us this number. Okay? Scott, put in your calculator square root of 6. Tell me what that equals.
2.4494.
Okay, so when we get here, this will say negative 2.44. Okay? All right, negative 2.44. That's the negative square root of 6. Okay? Any questions on that? So what two buttons did I push to get to that menu, that calculate menu? Second trace, right next to graph. All right? And then we're looking for 0. Okay? Left bound, so get the cursor left of it, enter. Right bound, cursor right of it, enter. Guess, just hit enter, and it'll find it for you. You just have to tell it where to look for that 0. Okay? That's what left bound or right bound means. Okay? Anything else up to 20? Okay. 21. 0 is a 0 with a multiplicity of 2, and 8 is a 0 with a multiplicity of 3. Okay, we'll go over that one in a sec. And then 22, negative 3 works once, and 2 works with a multiplicity of 2. That only gives me 3 of them, right? And I should have 4 of them. All right, I'll have to look at that one. Maybe both of them have a multiplicity of 2. Maybe that's what it meant. It says negative 3, comma 2 with a multiplicity of 2. So maybe both of them have a multiplicity of 2. Anyway, I'm going to look at 21. Okay, and I'm just going to put it in my calculator. You got some big numbers there, doesn't it? Okay. So 8x to the 5th minus 192x to the 4th plus 1536 x cubed minus 4096 x squared. That's it. Way over here. Looks like 1, 2, 3, 4, 5, 6, 7, 8. All right. So if I were to try to factor this, what could I factor out of it? To start. An 8x cubed? Just squared? Okay, so then I'd have x cubed minus, what's 192 divided by 8? 24? That was x to the 4th, so this is x squared. What's 1536 divided by 8? You got it, Olivia?
192.
Thanks. That would just be x, right?
192.
Sorry, I forgot my 2. What's the last one?
Minus 512.
Thanks. Okay, so what's this 0 over here? That's 0, right? Because of this. How many times does it work? Twice, right? So we go to our table, or picture, we only see 1 here. there's one, okay? But we're thinking it's 8, yeah. Okay, so I'm gonna do 8. Put a 1, a negative 24, a 192, and a negative 512. I get 8, and what's that? 16? And what's 8 times negative 16? 48, 128, which is 4 and 6. And 8 times 64 is 512, right? How do I get so smart? Okay. Now, looking at the graph, it doesn't look like it bent, does it? But I'm going to check, see if it works again. All right? That wasn't a very good look at it, but I'm going to try 8 again, just to see what happens. 1 times 8 is 8, and that's a negative 8, and that's a negative 6. So it did work again. So since it wasn't bouncing, I'm thinking it bent, and sure enough, it did bend. So 8 worked 3 times. And there's my 5, right? It started out as x to the 5th, right? So x equals 8 3 times. Questions? Is this helping, going over it slowly today? Those of you that had some question marks. Does anybody have a certain specific question, whether about calculator or just the procedure, and not worried about what's on their phone? No questions? Okay. What I would like you to do, some more practice, nothing new, just more practice of this stuff. Page. Where is it? 443. Numbers 24, 26, 30, and 33. 4 problems. Yes, sir.
We're putting up on the board.
What's that?
Can you like put the tables on, like, can you open up on the board?
I don't understand what you're asking.
Like put the books up. Oh, that's the
Oh, that's the homework.
one.
Yeah. This is your homework. 4 problems.